Okay, Chapter 5, Day 7 video. Today what we're going to focus on is graphing complex numbers and multiplying complex numbers. Graphing is a very small piece, so I'm just going to put it in here, but we're going to graph them and then we're going to multiply them. So first of all, graphing complex numbers. Let's take a look. It's on an axis that looks like an XY axis, except the axis has a real part and the imaginary part. Okay? Well, when I'm graphing complex numbers, that's the real part. This is the imaginary part. So this is like the X and this is like the Y. Positive 3, so come over 3, up 4, make a dot. Now, graphing complex numbers, here's what's different. We graph them as an arrow starting at the center out to the dot, and then we label it 3 plus 4i, and we're done. That's how you graph a complex number. I can graph the sum of complex numbers, and if I do that, I graph one of them first, 2 plus 3i, so go over 2 plus 3i, 1, 2, 3. Okay, so there's my first one. And I'm going to label it 2 plus 3i. And now what I do is I start where this left off and then graph this one. So we'll do this first and then do this one second. But the second one, you start here. You start at where the first one ended up. So the second one, we're going to start here. I'm going to go minus 5 in the X. So I was at 2, so 1, 2, 3, 4, 5. It comes all the way over to minus 5. From here now, minus 5. And then down 2. So minus 5 down 2 puts me right here. Again, you're counting from the tip of this one. So you graph tail to tip when we graph. Tail to tip, tail to tip. So there's this one, my arrow. And this one is negative 5 minus 2i. Now, if I want to graph the sum, I've graphed the first one, graphed the second one, but my sum is now what I get when I go from the center out to wherever that ended up. And this one will be the sum. And that sum is 1, 2, minus 3 plus 1i. And I don't have to put the 1 there, I could just do plus I. But that's graphing complex numbers, is just graphing arrows. And if you're graphing more than one, you go tail to tip, tail to tip. And that's graphing. Let's take a look at multiplying. This occurs a lot more in our year, all right? So multiplying complex numbers. You multiply like it's a variable. All the exponent rules apply. So I to the third times I to the fourth, I to the seventh. Adding exponents when we multiply. But then you have to simplify. All right, you have to put it in simplest form. So I to the seventh, well, if we go to our chart, we have I, negative 1, negative I, 1. Remember, I to the first, I squared, I to the third, I to the fourth. If you can remember those four, you can do I to the seventh. 1, 2, 3, 4, 5, 6, 7. Our answer is negative I. I to the first times I to the 11th is I to the 12th. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Answer is 1. Also, if we divided 12 by 4, our remainder would be 0. I to the 0 is 1. If we divide 7 by 4, our remainder is 3, which is the same as I to the third. That's how we're getting negative I. So you could do either way. Just like if this was an X, 2 times 5 is 10. I squared I to the cubed would be I to the fifth. Remember, we're adding exponents. I to the fifth, 1, 2, 3, 4, 5. So this is 10i. Let's take a look at if we multiply now binomials. You multiply them just like it's an X. You're still going to go first, then outer. So 3 times 2 is 6. 3 times a negative 5i is negative 15i. 4i times 2 is 8i. And 4i times a negative 5i is a negative 20i squared. Now you have to clean it up, all right? So we FOIL it, now we got to clean it up. So combining like terms, well, I have a 6, a minus 15i's add 8i's is a minus 7i's, minus 20, but I know I squared. Remember, I squared is equal to negative 1. You have to remember that because it occurs in every single one of these problems. I squared is negative 1, so instead of I squared, I'm going to put negative 1 there. So now I have 6 minus 7i. A negative 20 times a negative 1 is plus 20. So now I have 20 plus 6, which is 26, minus 7i. When I write it with the number without the I and then the number with the I, we say that this is in a plus bi form. So anytime you hear a question that says, write your answer in a plus bi form, what they're talking about is when you get all done, you should have a real part and an imaginary part, or maybe you don't have a real part or imaginary part, but when you have both, the real part has to come first, then the imaginary part. And you may say, well, it says plus. Well, plus or minus, however you want to say that, but it's real part, then imaginary part. So let's put this one into a plus bi form as well. So 3 times 3 is 9, minus 3i, plus 3i, minus I squared. Can you see what's going to happen here? The positive 3i and the minus 3i are going to cancel each other out. I'm left with 9 minus a negative 1. Well, minus a negative, same thing as plus 1. So 9 plus 1, that's just 10. Do you remember when radicals had like 3 plus square root of 5, 3 minus square root of 5? Okay? Remember, i's are really radicals. When we have binomials that are the same, two terms, but different signs, we would say that these are conjugates. Okay? These are conjugates. And the same thing happened. Because they're conjugates, the middle term cancels out and we're left with just a real part. If they're conjugates, your answer will only have the real part. And that's fine. That will help us out when we divide next class. So that's multiplying and graphing.